Solving quadratic equations in one variable by taking the square root. We'll start by squaring some numbers. To square a number means multiply it by itself. 4 to the second power, or 4 squared, equals 4 times 4, or 16. Negative 3 squared, negative 3 times negative 3 equals positive 9. 0.6, or 6 tenths, times 6 tenths would be 36 hundredths. To square a fraction, we square the numerator and the denominator. To take the square root of a quantity, we think what times itself equals the quantity. So the square root of 36x squared would be 6x. The square root of 25 is 5. Square root of negative 4. Is there a number which, when multiplied by itself, equals negative 4? No solution exists for the square root of a negative, no real solution. All right, the square root of 50, we can't get an integer value for that because 50 is not a perfect square. However, we can simplify that expression by rewriting 50 as 25 times 2. We can take the square root of 25, it's 5. And so 5 radical 2 is the simplified version of the square root of 50. Here we have two equations. We're asked to solve each equation. In other words, find the value or values of x that make each sentence true. In example A, x is being squared. The inverse operation would be square root, so we can take the square root of both sides. But we want to remember that x can equal 5 or negative 5, because 5 squared will equal 25, but negative 5 squared will also equal 25. Example B will start off the same way. We'll take the square root of both sides, but then we'll notice that there's a negative underneath the radical, therefore there is no real number solution for example B. Notice in both examples, the variable x squared was isolated. In the next two examples, we'll have to isolate the x squared term. Okay, so let's subtract 3 from both sides in example A. We get x squared equals 49. We can take the square root of both sides, and we get x equals plus or minus 7. So there are two solutions that would make that given equation a true statement. Example B, let's add 100 to both sides, and then we'll divide both sides by 4. X squared equals 25, and there are two solutions to solve this equation. When we take the square root of both sides, we get x equals plus or minus 5. Typically, we'll expect in a quadratic equation 2 real solutions. There'll also be some examples where there's no solution, right, if there's a negative underneath the radical. And there might be a type of equation where there's only one solution. So we'll be thinking about those as well. All right, here's an equation where when I go to take the square root of both sides, I notice 40 is not a perfect square. However, I can simplify this radical by rewriting it as 4 times 10. And so the solutions would be plus or minus 2 square root of 10. That's the exact solutions, but the direction said to approximate. So I can use my calculator and I can round to the nearest thousandth. And the values of x that would make this true are approximately plus or minus 6.325. Example B, we want to isolate the variable term, so we'll add 24 to both sides. Now we'll divide both sides by 8, and we get x squared equals 15.5. When we take the square root of both sides, we understand that we'll need to use a calculator because there's no known integer or terminating decimal, which multiplies by itself to equal 15.5, but the calculator rounded to the thousandths place, the solution would be about positive and negative 3.937. So again, we're solving quadratic equations in one variable. And sometimes we'll have a word problem. Malik covered a cube with 864 square inches of self-stick vinyl. What is the side length of the cube? Well, if Malik used 864 square inches, we're talking about surface area, right? And because there's 6 congruent faces on a cube, the formula for surface area is 6s squared. Now we know the surface area, we don't know the side length. So to solve this for s, let's divide both sides by 6. Let's take the square root of both sides, and we get plus or minus 12 inches. Very often with word problems, one of these solutions will be extraneous. It will not make sense in the context of the problem. And in this case, you can't have negative length, right? So there's one solution to this problem, and the longest possible side length of the cube would be 12 inches. So we want you to try a couple of examples here. Remember, when solving quadratic equations, isolate your x squared term. When you take the square root of both sides, very often we need plus or minus in our solution. And we cannot take the square root of a negative. And finally, if you're trying to find the square root of something which is not a perfect square, you will need a calculator and round to the nearest thousandth.